Hello friends, welcome to this channel. Guys, we have learned a lot of things about Amazon Route 53 like how to create records, what is TTL, CNAME, alias and all these things, right? So now let's talk about routing policies for Route 53. So a routing policy is helping Route 53 respond to DNS queries, and we should not be confused about the word routing. This is not like when you have a load balancer and the actual load balancer will route traffic to the backend EC2 instances. No, this routing is from a DNS perspective. So the DNS does not respond, does not route any traffic. So the traffic does not go through the DNS. The DNS only will respond to the DNS queries, and then the clients will know to which way they should be doing these HTTP queries, for example. So the DNS just helps translate host names into actual endpoints that the client can use. So Route 53 will support the following routing policies. There is simple, weighted, failover, latency based, geolocation, multi-valued answer and geo proximity. And we are going to have a look at some of this in this session. So the first one is going to be the simple routing policy, and the idea is that with this that we have actually been using before, we are going to route traffic to a single resource typically. So here is an example. The clients that will say, hey, I want to go to foo.example.com, and Route 53 will say, hey, go to this IP address and this is an A record. So it is possible for us to specify multiple values in the same record, and if multiple values are returned by the DNS, then a random one will be chosen by clients or client side. So in this example, we have the clients asking again for food.example.com, and Amazon Route 53 will just reply with three IP addresses that occurs embedded into the A record, and then the client will pick one of them randomly and apply it for the routing. So if you have enabled an alias record alongside the simple policy, then you can only specify on AWS resources as a target. And finally, it's called simple because it's very simple, and therefore you cannot associate this with health checks. So this is what simple routing policy is. So now let's talk about the weighted routing policy. The idea is that you can have a percentage of requests you can control to go to a specific resource. So put it simple in the diagram. We have Amazon Route 53, and then we have three EC2 instances that have been assigned different weights. So 70, 20 and 10. In my example, this weights sum up to 100, but you don't have to in the real life, okay? But what this means is that 70% of the DNS responses from Amazon is on Route 53 are going to be redirecting to the first EC2 instance, then 20% to the second and 10% to the third. So what we have to do in our weight is to assign each record a relative weights, and then the traffic percentage is going to be sent to each record is just the weight of the record divided by the sum of all the weights of all the records, which is like a percentage of all the weights. Okay, the weights don't need to sum up to 100. They are just indicative of how much we want to send to this instance compared to all the other records in your DNS name. So to make this work, the DNS records must have the same name and same type, and you can associate them with health checks. Although we have not seen with health checks are again yet, but we will have a look at them very soon. Now the use cases for weighted routing policy is pretty obvious, is to do for example load balancing, maybe across different regions, or to test a new application version by sending a small amount of traffic to it, and so on. And then if you are sending to short or a weight of 0, then you are going to stop sending traffic to a specific resource, so you can shift weight over time. And if all the resource records will have a weight of 0, then all records will be written with equal weights. So that's it for this weighted routing policy. Now, let's talk about a routing policy that's super easy to understand, which is the latency based routing policy. Okay, so now let's talk about latency based routing policies. And the idea is that you want to redirect the resource that is going to have the lowest latency. So the closest to us, which is super helpful when latency is is your main concern for your website or applications. Now, latency is going to be measured based on how quick it is for user to connect to the closest identified AWS region for that record. So, for example, if user in Germany and you have the lowest latency to a resource in the US, then this is where you will be redirected, and this can be combined with health checks. So let's have a look at the map of the world to understand it. Say we have deployed our application in two different parts of the world. One is US East 1 and one in AP Southeast 1. Then the users are all around the world, and the latency is going to be evaluated by Route 53. And so the users closest and with the lowest latency to the ALB US East 1 will be redirected there, whereas the other users will be redirected to AP Southeast 1, right? Okay, so now let's talk about failover routing policies. So the idea is that we have Route 53 in the middle and we have EC2 instances. One is going to be our primary EC2 instance, and the second one is going to be a secondary or disaster recovery EC2 instance. In this case, what is going to happen is that we are going to associate our primary record with a health check, and this is mandatory. And if the health check it becomes unhealthy, then Route 53 is going to automatically fail over to the second EC2 instance and start sending that result back instead. And of course, the secondary EC2 can also be associated with the health check as well if we wanted to. But there can be one primary and one secondary. Now, the client, when it makes DNS requests, will automatically get the resource that is deemed healthy. Okay, so this is what failover routing policy is. Now, let's talk about the routing policy geolocation. which is very different from latency based. So this is based on where the user is actually located. So for example, you can say if a user comes from a specific continent or a country, or even more precise on the US states, and the most precise location is going to be selected at first, then routed to this IP. So you should create a default record, and in case there is going to be no match on location, and the use cases for this is going to be for website localization, to restrict content distribution, do load balancing, and so on. And this type of records can be associated with health checks. So the idea is that if we have a map of Europe with multiple countries, we can define a geolocation record for Germany to see the German user should go to this IP, which contain my German version of my app. And if I go to France, then go to this IP, which contains a French version of my app. But for anywhere else, go to the default IP here, which contains maybe the English version of my app. So this is how you would use geolocation. I hope you all guys are clear with this. In the next session, I'll give you hands-on demo of this. So stay tuned. If you have any doubt, feel free to ask in the comment section below. We will happy to solve your doubt. Thank you for watching. Bye and have a nice day.